look at standard S4. You've probably seen this formula before. We worked on it a little bit yesterday in class if you were in class. But in case you haven't, it's a super useful thing to know. If I can talk right. It's useful because it solves any quadratic. Now we've talked about two ways to solve quadratics already. We've talked about factoring and we've talked about completing the square. But there are situations where factoring isn't possible, and then when we complete the square, there's some situations where you end up getting lots of different fractions and it just becomes really messy. So having another method to use that solves any quadratic is nice. More options means you have more choice to get to the same result. We did an explanation in class, and actually it was in a link that I sent you when the sub was here on Tuesday, of why the quadratic formula can solve any quadratic. And why does it? Well, it does because the quadratic formula results from completing the square of ax squared plus bx plus c equals 0. So when we complete the square or do the method, which we know completing the square is the method that we've used before to solve quadratics, when we complete the square of a quadratic, that means we get the two answers at the very end. That are my two x-intercepts. Well, when you complete the square with not numbers but with letters, you end up getting the quadratic formula. And the quadratic formula is nice because that means you only need the numbers from the problem, plug them into the formula, and it punches out your answer. So quadratic formula, you have to have this memorized. This is not something that's going to be given to you on the test. A lot of you recognize it, which is good, but you do have to know what it is. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. A little note here, your quadratic must be in standard form set equal to 0 before using the formula. Okay? Otherwise, you're not going to know what your A, your B, and your C are. So if we look at example 1, and I asked you to solve, let's go with 4x squared plus 5x equals 7. If I asked you to solve this using the quadratic formula, your first step would need to be to move the 7 over. Because in order to figure out what your A, your B, and your C are for the quadratic formula, you need to have it lined up in that way. So then I always label what my A, my B, and my C are down the left-hand side. It isn't something you have to do, but I like just dealing with straight numbers. So my A value is 4, my B value is 5, my C value is negative 7. And then until you have the formula memorized, I want you to write it out every time. Because the more you write it out, you're gonna remember what it is. And then we plug in the numbers where they go. So my B value is 5. That's going to go in for B here. It's going to go in for B here as well. A is 4. C is negative 7. All over 2 times A. And then we simplify. So we have negative 5 plus or minus. In this case, you get 25. And then I'm going to go ahead, grab a calculator here, multiply. Move this a little bit. To multiply. So you could do this all in one step here. So 5 squared minus 4 times negative 7. You end up getting the square root of 137 all over 8. Now, if this number isn't a nice number, meaning you can't take the square root of it and have it be a nice number, then that's where we stop. And that's fine. Leave your answer like this. You still have two answers because you have the positive and the negative version. So we still, if we punched out to a decimal, you would still get 2x-intercept. And flipped. Okay, so we're going to do another one. So solve. Let's go with, I don't know, 5x squared. Did I use 5? Nope. 5x squared minus 8x plus 2 equals 0. Okay, and then we're going to label my A, my B, and my C. My A is 5, my B is -8, and my C is 2. And then in my formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. I'm going to go ahead and plug in the information where it belongs. So my b is -8. So negative b is a negative 8. B squared minus 4 times a times c all over 2 times a. Negative negative ends up being +8. Negative 8 squared. When you put in a negative number and square it in your calculator, you need to make sure you have parentheses around it. And then we're going to subtract 4 times 5 times 2, and I end up getting 24 over 10. And then I'm just going to have you leave it like that, because 24 doesn't have a nice square root. Alright, and that's where we're going to stop in this video, at least, for S4. And then I want you to go back to example 3 and complete the square. We're going to do one example of that. And this is the first method that we were working on with completing the square. So we're going to look at the function 3x squared plus 15x minus 2 equals 0. We're going to complete the square with this problem. First step with completing the square is to add c to either side, or move c to the other side. So I'm going to add 2. Then your next step is to divide everything by a. So I get x squared plus 5x equals 2/3. Now, don't make things decimals. Decimals actually, in this case, make things more difficult. Just keep it as fractions. And then we're going to go ahead and do the completing the square part. So the completing the square step here is take half of b. So half of 5 is just 5 halves. We're going to square it. When you square a fraction, you square the top and you square the bottom. So we have 25 over 4. And then we're going to add 25 over 4 to both sides. Okay. On the left-hand side, this sets me up to factor. Now, I need two numbers that multiply to get 25 over 4 and add to get 5. Now, it's hard to think through that, but remember the little trick is whatever half of b was, that's what goes in the parentheses. So I'm going to throw 5 halves in there, and then it makes sense. 5 halves times 5 halves gives me 25 over 4. 5 halves plus 5 halves gives me 10 halves, or 5. So it does work out that way. And then I have to add these two fractions together, which means I need common denominators. The common denominator here is going to be 12. So 4 by 3 over 3. 4 over 4. And I'm going to be adding, I'll kind of do this in two steps here, 8 over 12 plus 75 over 12. Okay. And then I'm going to rewrite the left-hand side as a squared binomial. And then 8 plus 75 is 93. 12. Okay. And then we're going to take a square root of both sides. So when I take the square root of both sides, we get x plus 5 halves equals plus or minus the square root of 93 over 12. Now at this point, I'm going to let you leave it like that. because 93 and 12, neither of them have a nice square root. So I'm just going to move the 5/2 over by subtracting it. I'm going to stop there. All right. And that is it for that whole video.